Hello folks, we quickly come to this part 2 video of this exercise 5.3 and we are going to see another lot of questions. Same thing, implicit functions, we are going to take the derivatives, taking derivatives on both sides and only being a little careful when a y derivative comes. That's all. So by now we have got used to how to deal with it. So let's continue. Now this is our question number 5, which says that x squared plus xy plus y squared equal to 100. We are taking the derivatives on both sides with respect to x. So it is x squared plus xy plus y squared equal to derivative of 100 with respect to x. So it is actually derivative of x squared, derivative of xy and derivative of y squared and derivative of 100. Right. Now derivative of x squared with respect to x raised to n has got the derivative n x raised to n minus 1. By that we know the derivative of x squared is 2x. So this is 2x. This is product, right? So it is x times derivative of y plus y times derivative of x. Next, derivative of y squared but with respect to x. So first we will find derivative of y squared with respect to y, then we will account for the x. So derivative of y squared with respect to y like this is 2y, but because it is with respect to x, we will also write dy by dx. On the right hand side, fortunately, it's a constant, and constant when we find the derivative becomes 0. So the right hand side is 0. Now let's take the other part. So here we are left with now 2x plus x dy by dx plus y dx by dx, we have learned it's 1, plus 2y times dy by dx equal to 0. These are clubbable. So you will have dy by dx times x plus 2y, and the other two terms we might push it on the other side, minus 2x minus y. So finally your dy by dx becomes minus 2x plus y by x plus 2y. That's what. That is our dy by dx. Somewhat identical is the next. So that also we will do d by dx of taking the derivatives on both sides, x cubed plus x squared y plus xy squared plus y cubed and derivative of 81. Now we have learned that derivative of a constant is 0. So at the very first step we will drop it so that we don't have to keep on carrying it throughout. So what happens is this will become derivative of x cubed plus derivative of x squared y plus derivative of xy squared plus derivative of y cubed equal to 0. Right? Now let's account for all this. Derivative of x cubed we know by the formula n x raised to n minus 1. It is going to be 3x squared. This is a product. So it is it is x squared times dy by dx and y times derivative of x squared with respect to x. Again here, x times derivative of y squared with respect to x plus y squared times derivative of x with respect to x. Last, it is derivative of y. Let's find this. 3x squared we have already found. X squared derivative of y with respect to x, not much to do. Y derivative of x squared with respect to x. Derivative of x squared is 2x with respect to x. So it is 2x. Derivative of y squared with respect to x is 2y, but because it's a y function, you have to write dy by dx. Then y squared dx by dx, of course, is just y squared plus y squared plus y cubed with respect to x means first the derivative of y squared, y cubed, which is 3y squared, like what we did here. But because it's a function of y, we have to write dy by dx equal to 0. Finally, we will bring all the dy by dx terms together. What all is there? Here there is this x squared, here there is this 2xy, here there is this 3y squared. And the non-dy by dx terms, we will take it on the other side. Minus 3x squared, minus 2xy, this is there, and this is there. Minus y squared. Therefore, your dy by dx term is going to be minus 3x squared plus 2xy plus y squared time by x squared plus 2xy plus 3y squared. That's all. Right? So that's about this problem. Once we are done with that, we are quickly moving to the next problem, and the next problem is, they are all almost having the same flavor. This is trigonometry. Sine squared y plus cos xy equal to k. See, it's a matter of time. When we keep on doing it at one shot only, we will be able to do it. Now, because we are beginners, maybe we may not be able to get it at one shot. So what we will do is, for our convenience, let's call this function as u, let's call this function as v. Get their derivative separately, then come back and try to do it. Okay, so maybe first let us call u as sine squared y. Our idea is to get du by dx, right? So this looks a little complicated, so we will do a further substitution. Maybe that means it is sine y raised to 2. So we will make a substitution, maybe w as sine y. So u becomes w squared. Automatically we require its derivative. Y is in terms of w is in terms of y. Let's find the derivative. It is cos y, and u is in terms of w. So du by dw is 2w. Now I have told you right from the beginning, where we require the derivative with respect to x. So you require du by dx. And how we can frame out of all this? U is in terms of w. So du by dw to start with. W is in terms of y, and we want it in terms of x. Just see, no, it's just putting pieces together. Whatever we have, we are putting it together. We know u in terms of w, you know w in terms of y, and we know we want du by dx. So we are putting things together and applying the chain rule. So what is coming here? Du by dw, it is 2w, then d, that is cos y, and this is going to be dy by dx. For the time being, let it be like that, and towards the end, when we put things together, we will get it all in terms of x or y or whatever. Right, so that is du by dx. And now this is only this part of the function. We will call this part of, and let v be cos xy. Now here also you want dv by dx. So for that, this is a problem, because it's a complicated function. So we will make yet more substitution. Let say z be xy, and like that v becomes cos v. So let's get dz by dx, because it's always x, that is what we are targeting. So dz by dx, because it's a product, is x times dy by dx plus y times dx by dx, and v is in terms of z. So dv by dz will become minus sin z. All this has to be intelligently put together. Therefore, dv by dx is our intention. And how are we going to get that? dv by dz we already have, and dz by dx we have found out. So what is happening? This is minus sin z. And what is dz by dx? It is x into dy by dx plus y, because dx by dx we know is 1. Okay. Given is u plus v, actually, according to our assumption, equal to k, right? We want derivative dy by dx. So therefore, first we will take the derivatives on both sides. It will be du by dx plus d by dx of u plus v. So that is du by dx, dv by dx equal to d by dx of k. I don't know whether I should write it like this. I don't know whether some folks will be confused. D by dx of u plus v, right? This will simplify as, we can scrap this. If it is too complicated, there's no point of cloud. So that is d by dx of u plus d by dx of v, and d by dx of k, which is a constant, is obviously going to be 0. Now du by dx, that's what they intend. We have it. 2w cos y dy by dx, and dv by dx also we have there. minus sine z into x dy by dx plus y equal to 0. It's a complicated lot. You have to simplify it. So w and all will come back. Is sine y. Y and x only is allowed. Sine y cos y dy by dx. Sin z also we don't know. Sine xy. X dy by dx plus y. We are almost done, but we are not actually done because dy by dx is what we require. This can be written as sine 2y. Sine 2y dy by dx minus x sine xy dy by dx minus y sine xy equal to 0. Right? Dy by dx can stay here. Other terms you can take on the other side. So dy by dx times sine 2y minus x sine xy is equal to y sine xy. So your dy by dx becomes y sine xy by sine 2y minus x sine xy. I will give it a quick check. Alright. Okay, so that's how it is. So next is going to take the flavor of this problem, but that will take it in the next part. Thank you.